We are going to start now the next lecture, lecture 3 of chapter 13, class 10th mathematics. It is volume and surface area of solids. In this lecture, we will talk about the volume and surface area of a frustrum of a cone. So first we are defining what is frustrum of a cone. So we are saying, suppose we have a complete cone, and if we cut some portion from the cone, we are saying that a line, this plane is there, and we have cut some portion of this cone, and these two planes, we are saying these two are parallel to each other. So we have removed this portion, this upper portion of the cone, and we will be left with some figure in this form over here. So the remaining portion between the plane and the base is called the frustrum of the cone. So we are saying we have considered this plane parallel to this base. We have removed this portion of the cone. So this remaining part of the cone that is left between these two, it is called the frustrum of the cone. So we are saying that R, this capital R, it is the radius of the base, and this small r is the radius of this top portion. It is not the cylinder, because this angle over here, this is not 90-degree angle. When we are talking about right circular cylinders, this angle was 90 degrees. So this is basically the portion of the cone. So we are saying this small r is the radius of this upper part, and capital R, it is the radius of this lower part, and the height, this height h is there, and this is the slant height L for this frustrum of cone. Then we have the formulas in the form that the volume of the frustrum of the cone, that is equal to pi h by 3 into r square, capital R square, plus small r square, plus capital R into small r. The formula for the lateral surface area, we have, it is pi L into r plus capital R plus small r, and the value of this cap L square, the slant height of this portion of the cone, it is given by h square plus capital R minus small r square units, and the total surface area of the frustrum of the cone, it is given by the formula, it is area of the base. The base, it is a circle. The area of the top part, it is a circle, and the lateral surface area that we have already defined, the sum of all these three values, it is given by this formula. Now next we are going to derive all these formulas. So before deriving the formulas or finding the values of the volume and the surface area, we look at some terms over here and calculate the values of the slant height and other values corresponding to this frustrum of the cone. So we have considered a complete cone. We are talking about this complete cone O A B. We are talking about this complete figure O P A B Q O. This is the complete cone we are saying. And suppose it is cut at 2 points. These are the 2 points P and Q, where the plane is intersecting with this cone. A plane is there parallel to the base. It intersects over here. Then we are considering that this base radius, it is capital R, and the radius of this circle, it is small r. The height of this complete cone we have, it is capital H, and the height of this smaller part, this frustrum of the cone, it is small h. And the third thing we have is that the length of this original cone, it is L1, and the length of this portion, it is small l. So what we get is the length or the value of this OD, this length we will have, it is capital H minus small h. This length OP we will have, it is L1 minus L. These are the lengths that we will, these are the values that we will have. Now if we look at the two triangles, one is the triangle ODQ and second is the triangle OCB. we can see that the angle at C and this angle at D, both these angles, these are equal to 90 degree. These two lines, we are talking about this line PQ and this AB, both these lines, these are parallel to each other. So these angles at Q, these are equal to each other. And this angle at O, this is the common angle. So what we get is that both these triangles, these are similar to each other. So we are talking about two triangles. One is the triangle ODQ and second is the triangle OCB. The lengths corresponding to these triangles, the length OC we have, that is equal to capital H. OB we have, that is equal to L1, and CB we have, it is equal to R, and DQ we have, it is equal to small r. OQ that we have, it is L1 minus L, and the value of OD we have, it is capital H minus small h. So if both these triangles, these are similar to each other, so what we get is capital H over small h over capital H, the ratio of the two sides. This is equal to L1 minus L over L1. This is equal to R over capital R. Now, if we consider these terms, capital H minus small h over h and R over R, we will get, on cross multiplying, we are getting the value that it is R into H minus H, that is equal to H into R. So what we get is that HR minus small h into R, that is equal to H into R. So this gives us the value of capital H is equal to small h into R over capital R minus small r. This is the value we are obtaining for capital H. Similarly, if we are comparing these two terms, we are talking about these two terms, we will get the value of L1 is equal to L into R over capital R minus small r. This is the value of L1 that we will have. So moving on to our next slide, we are having these two values. Now if we are calculating the volume of the frustum of this cone, so we are saying the formula for the volume of the frustum of this cone, that will be equal to the volume of the complete cone OAB, the volume of this complete cone minus the volume of this smaller portion. If we subtract these two values, so the volume of the complete cone we have, it is 1 by 3 pi r square h, capital H we are talking about. The value of height over here, the value of this height we have, it is capital H minus small h. So the volume of this portion, it is 1 by 3 pi r square. The radius over here, it is small r, the radius over here, it is capital R. So we are saying the answer we have obtained, it is in this form. Now if we substitute the value of capital H in this equation, the capital H in this equation, and solving these all terms, we will obtain the final formula in this form. That is the volume of the frustum of the cone, it is equal to this. Similarly, when we are calculating the curved surface area, we are saying we are calculating the curved area of the larger cone. It is pi r into L1, or we are writing it as pi r into T minus pi r into T minus L. So this T minus L, we are saying it is L1. This is L1 we have written, that the slant height of the larger cone, it is L1, and the slant height of this part over here, this slant height, we are saying it is L1 minus L. So on subtracting these two values and substituting the values of L1, the value of L1 we have already calculated. It is from the previous slide, we have substituted the value of L1 over here, and on solving this we will obtain the formula that the curved surface area of this cone, that is equal to pi times capital R plus a small r into L. So to calculate the volume and the area, we have used the similarity. By using the similarity, we have obtained the relationship between capital H and small h, L1 and L. And how we have calculated the volume? The basic formula we have used is, we have calculated the volume of the larger cone and we have subtracted the volume of this smaller cone. Then we have substituted the value of capital H and we have obtained the formula for the volume for the frustrum of this cone. Similarly, we have calculated the surface area of the frustrum of this cone. So it is important to note over here that whenever we are calculating the volume or the area of the frustrum of the cone, we do not require the dimensions of the original cone. The formula that we will have, it contains a small h only over here. It means it contains the height of this frustrum, the radius of the upper and lower portion. Similarly, when we are calculating the area, it is containing, the formula is containing the slant height of the frustrum, upper and lower radius, the circles that we have, the radius of both these circles. We do not require this L1 value. The formula we have, we do not require the height or the slant height of the original cone. So based upon this, we are going to solve some problems. The first problem we have is, an open metal bucket is in the shape of a frustrum of cone of height. The height of this bucket, it is given to be 21 centimeter. With radii of the lower part, the radii of the lower part means R, we are saying this is equal to 10 centimeters, and this is capital R, we are saying this is 20 centimeter. The height is given to be 21 centimeter. We have to find the cost of milk which can completely fill the bucket at rupees 30 per liter. So we have to find basically the volume of this bucket, and the formula for the volume we know, it is 1 by 3 pi h into capital R square plus a small r square plus capital R into small r. If you are not able to remember this formula or you forget this formula, what you will have to do is, you will complete this cone. I'm just saying you should remember this formula. If suppose you forget this formula, you complete this cone, consider this height to be h, then apply the previous formula that we have already seen. We are saying we have two triangles over here. This is say point O, this is A, B, C and D. So what we have is, this height we have, this is capital H minus small h. So what we have is capital H minus small h over capital H, that is equal to capital R over small r. So from this you can calculate the value of capital H. Put the values of small r, capital R and h, you will get the value of capital H. Then next step you have to do is, you have to calculate the volume of this cylinder, this cone. You have to calculate the volume of this larger cone and you have to subtract both these values, you will get the answer. But you must remember these formulas, you must learn these formulas, so that you need not to do all these calculations. So the values we have, we substitute the values over here. It is 1 by 3 into 22 by 7 into the value of h we have, it is 21 into, it is 20 square plus 10 square plus 20 into 10, and on solving this the answer we will get, it is 15400 centimeter cube. Now we know that 1 centimeter or we are saying it is 10 centimeter is equal to 1 decimeters. 10 raised to the power 3 centimeter cube, that is equal to 1 decimeter cube, and 1 decimeter cube is equal to 1 liter. So we have 1 liter is equal to 1000 centimeter cube. So we are saying by using this formula 1000 centimeter cube is equal to 1 liter, we get this value is equal to 15.4 liters. So this is the amount of the milk that we have. The cost is given to be, the cost of the milk is given to be, for 1 liter the cost is rupees 30. So for 15.4 liters the cost will be this into 30, and the answer comes out to be 462 rupees. So we are saying the cost of the milk will be 462 rupees. Now the next question we have is a bucket open at the top and made up of metal sheet. It is in the form of a frustrum of a cone. So a bucket is there in this shape, and the depth of the bucket is given to be 24 centimeter, and the diameters of its upper and lower circular ends are 30 centimeter and 10 centimeter. So radius of the upper end, it is 15 centimeter, and radius of this lower end, it is 5 centimeter. Find the cost of metal sheet used in it at the rate of rupees 10 per 100 centimeter square. So these are the values given to us. This we are saying this is the value of capital R, this is the value of small r, and this is the value of H we have. So we have to find the cost of metal sheet used in it at this rate. So we are saying it is open from this side. So what we have to calculate? We have to calculate the lateral area, and we have to calculate the area of this base. The area of this base, that is given by pi r square, and the formula for the lateral area for the bucket, the lateral area of this bucket, the formula we have, it is pi L into r plus r. Now we have to calculate the value of this L, and to calculate the value of this slant height we are talking about, this slant height L we have to calculate. And to calculate this value, we are using the fact that this portion is in this form, that this is capital R, this is small r, and these 2 points, these are joined like this. This value we are saying this is H, this value is capital R, and this value is small r. So if we draw the perpendicular from this R on this side, this length we are saying this is R, and this remaining length over here, this will be capital R minus small r. This height, it is H. So the slant height we will have, it is capital R minus small r square plus H square. So on substituting these values, the answer we get for L, it is capital R, it is 15, and small r, it is 5. So it is 10 square plus H square, it is 24 square. On substituting these values, we will get the answer is 676, and that is equal to 26 centimeters. This is the value of L that we have. This is the value of L that we have. It is equal to 26 centimeters. Now, if we substitute the values in the formula for the area over here, we will get it is 3.14. We will have to take pi is equal to 3.14 into the value of L we have, it is 26, into H plus R, this value is 15 plus 5, plus the area of this circle, so it is 3.14 into 5 into 5. This value is shown over here, that it is 3.14 into 26 into 15 plus 5 plus 3.14 into 5 into 5, and when we solve this value, the final answer we will obtain, that is equal to 1711.3 centimeter square. On multiplying these values, the final answer that we will get on solving this, it is equal to 1711.3 centimeter square. Now the next thing that is given to us is that the cost of metal sheet used in it is at the rate of rupees 100 per rupees 10 per 100 centimeter square. So the total area that we have, we are saying for 100 centimeter square, the cost is rupees 10. So for this much 1711.3 centimeter square, the cost will be 1711.3 into 10 by 100, and the value comes out to be 171.13 rupees. So this is the total cost of the metal sheet. Now next we have is a bucket is in the form of a frustrum of a cone with a capacity of, the capacity of this bucket is given, it is 12308.8 centimeter cube of water. The radii of the top and bottom ends, these are given to be 20 and 12 centimeter respectively. Find the height of the bucket. So height of the bucket, we are saying suppose it is h centimeter, and the area of the metal sheet used in its making. So we have to calculate the value of h and L basically. So the volume of this bucket, it is given to be 12308.8 centimeter cube, and if we substitute the values in the formula for the area, it is 1 by 3 pi h into r square plus r square plus r into r. We are saying this is the value of capital R and this is the value of small r. So the answer we are writing over here, it is 1 by 3 into 22 by 7 into the value of height, it is h, the value of r square we get, it is 20 square plus 12 square plus 20 into 12. On solving this, we will get the value of h, that is equal to 12308.8 over, when we solve these values, the answer we will get, it is 3.14 into 784, and this value comes out to be 50. These calculations, these are shown over here. We are saying when we are equating these two terms, we have substituted the values over here. This is pi, then it is capital R square, small r square, capital R into small r. On multiplying these terms, we will get it is 784 into h. It is equal to this into 3 over here. This value we are saying, and the final answer we will get, it is h is equal to this. So you can check these calculations at your own, that whether you are obtaining the value of h is equal to 15 or not. Next, this is the first part we have solved, that what is the height of the bucket, the value of h we get, it is 15. Next we have to calculate the value of L. So the formula for L, how we have derived, we have drawn the perpendicular. This is h, this value it is capital R minus small r. So the formula for L we have, it is square root of capital R minus small r square plus h square. When we substitute these values over here, the answer we will get, it is square root of 15 square plus 8 square, that is equal to square root of 225 plus 64, and that is equal to 289, and that is equal to 17 centimeters. So this is the value of L that we have. It is the slant height, we are saying it is 17 centimeters. Next we are saying we have to calculate the area of the sheet used. So for the area of the sheet used, we are talking about the two things. One is this circular portion, and second we are talking about this part over here, that is the lateral area. So area for the circular portion, it is pi r square, the bottom portion we are talking about, and the area of the lateral area, the formula we have, it is pi L into r plus r, capital R plus small r. So when we substitute these values in this formula, it is pi 3.14 into L, the value of L we have calculated, it is equal to 17, then it is capital R plus small r, so it is 20 plus 12. The next values we have, it is plus 3.14 into 12 into 12 centimeter square. When we solve these values, it is 20 plus 12, and the answer we will get, it is equal to 32. So it is 3.14 into 17 into 32 plus 3.14 into 144, and on solving this the final answer we will get, that is equal to, when we substitute these values we are getting the answer, it is 2160.32 centimeter square. So you can multiply these values to obtain this answer, and this is the area of the metal sheet to be used. We have considered only one circle over here, this bottom part, because it is the bucket and it is open from upper side. Now the next question we have is, in the figure, from the top of a solid cone of height 12 centimeter. So a cone of height 12 centimeter is given to us, and the base radius it is 6 centimeter. A cone is removed, and we are saying the cone that is removed, we are talking about this cone, its height is 4 centimeter. So we have to find the total surface area of the remaining solid. It means we are talking about this frustrum of cone, and we have to find the area of this solid. So first of all we have to calculate the value of this radius small r. The value of this is capital R. So if we look at these two triangles, we are talking about the triangle OAB, and second triangle we are talking about, it is OCD. We are talking about these two triangles. This angle at C is 90 degree, this angle at A is 90 degree. This angle at O is common. So both these triangles, these are similar to each other. So what we get is, if this value we are saying it is capital H, this value we are saying it is small h. So we have capital H over small h, that is equal to capital R over small r. So the value of capital H, it is 12 over 4, that is equal to 6 over small r. So this gives us the value of r, that is equal to 6 into 4 by 12, and the answer we are getting, it is equal to 2 centimeters. The radius of this portion, it is 2 centimeters. Now if we look at this triangle over here, OAB we are talking about, this triangle we are saying this is OAB. This OA height we are saying it is 4 centimeter, and this AB length we are saying it is 2 centimeter. So length of this OB we have, that is equal to, if we substitute this values over here, it is 4 square plus 2 square. So the answer we will obtain, it is 16 plus 4, that is equal to square root of 20, and square root of 20 means it is 2 square root of 5. Now as we have already seen that these two triangles, these are similar to each other, and this length we are saying, say it is L, and this complete length, this length we are talking about, this complete length, say it is capital L. So what we get is that this value is equal to capital L over small l. This is the value of small l we have obtained. So the value of capital L we have, it is 12 over 4 into 2 root 5. When we divide this value, it is 3, so we get it is 6 root 5. So the length of this portion BC we are talking about, the length of this portion BC, that will be equal to the difference of these two values, it is 6 root 5 minus, it is 6 root 5 minus 2 root 5, and the answer we obtain, that is equal to 4 root 5. This is the value of this length. So we have obtained a frustrum of cone. We are saying the slant height we have, that is equal to 4 root 5. The radius over here we obtain, this is equal to 2 centimeter. The radius over here we obtain, this is equal to 6 centimeter, and the height we have over here, that is equal to, this height we are talking about, this height is equal to the difference of these two values, the value of this is 12 minus 4, that is equal to 8 centimeters. Now we have to calculate the area of this frustrum of cone, and the formula we know, it is the area of this smaller circle. The area of this smaller circle, it is pi into 2 square. Area of this larger circle, this bottom part, it is pi into 6 square. And area of this portion we are saying, the area of this portion, it is pi into the slant height we have, it is 4 root 5 into capital R, that is 6, plus small r, that is equal to 2. So if we add all these three values, we are talking about these three values over here, it is pi into 2 square, pi into 6 square, and pi into this value. When we add all these values, we will obtain the final answer as 350.592 centimeter square. So to solve these values, we have taken this pi and pi common from all these terms. So it is 22/7 over here, and rest of the calculations you can check over here. You can try these calculations at your own, and you can see that the final answer you will obtain on solving this, that is the area of this frustum of cone, it is 350.592 centimeter square. Now the next question we have is, an open metallic bucket is in the shape of a frustum of a cone mounted on a hollow cylindrical base made of metallic sheet. This is the base we are talking about. This is made hollow cylinder, and it is made up of the metallic sheet. If the diameter of the two circular ends of the bucket, they are, this circular end, the diameter it is 22.5 centimeter, and this diameter over here, this radius over here, that is equal to 12.5 centimeter. The diameters, they are 45 and 25. So the radius we have, it is 22.5 centimeter and 12.5 centimeter. The total vertical height we have, this total vertical height we are saying, it is equal to 24 centimeters. Why? Because it is given that the total vertical height is 30 centimeter. This total vertical height means we are talking about this height over here, this is 30 centimeters, and that of the cylindrical portion, this portion, it is 6 centimeters. So remaining height over here, it is 24 centimeters. Find the area of the metallic sheet used to make the bucket, and also find the volume of the water it can hold. So when we are calculating the area of the metallic sheet, we are saying there are three portions over here. One is this portion, that is the lateral area of the frustum of cone. Second is this base, this is also made up of the metallic sheet. And third portion we have, it is this cylindrical portion, which is made up of this metallic sheet. So the area of this cylindrical portion, it is the curved surface area of the cylinder, and the formula we have, it is 2 pi r h. This is the value of capital H we are saying. Suppose this is the value of small r, this is the value of capital R, and this is the value of this value over here, this will be the value of L, and this is the value H that we have. So when we are talking about this base cylinder, we are saying the height of this cylinder, it is capital H, and radius is small r. When we are talking about the area of this circle, the area of this circular base, it is pi r square, and the area of this frustum of cone, the lateral area of this frustum of cone, that is pi L into capital R plus small r. So when we add all these values, the answer we will obtain, we are saying it is pi is common from all these values. We are saying pi is common from all these values, and we are left with this L into capital R plus small r plus r square plus 2r h. On substituting these values in the formula, we will get it is 22/7 into the value of L we have, it is, when we have to calculate the value of L, we are saying the figure we have over here, it is, this figure is there, it is 22.5 centimeter. This length we have, it is 12.5 centimeter. This length we have, it is 24 centimeter. If we draw the perpendicular over here, the remaining length over here, that is equal to 10 centimeter. This length over here, this is 10 centimeter. So this length we obtain by this formula, that it is h square plus r minus h square, that is 24 square plus 10 square. And on solving this, the value you will obtain, it is square root of 576 plus 100 centimeter. This gives us square root of 676 centimeter, and the answer we obtain, that is equal to 26 centimeter. So we are saying this is the value of L that we have, that is equal to 26 centimeter. So it is 26 into capital R plus small r. So it is 22.5 plus 12.5 plus small r square, it is equal to, we are saying 12.5 square plus 2 into 12.5 into the value of capital H that we have, it is 6. When we multiply all these values, the calculation, these are shown on our next slide. We are saying we have substituted these values and we are obtaining the answer in this form. And when we substitute these values in this formula, we will get the answer in the form 22 by 7 into 1216.25, and on multiplying this, the final answer we will obtain, it is 3822.5 centimeter square. So this is the total area of the sheet that is required to make this bucket. Next thing we have to calculate is the volume of the bucket. So volume of the bucket means we are talking about this volume only, that whatever the liquid that can be contained in water, we are saying that can be there in this bucket. So we require, what we require is the volume of frustrum of cone, and the formula for this volume we know, that is equal to 1 by 3 pi H into capital R square plus a small r square plus capital R into small r. When we substitute the values in this formula, the calculation, they are shown on over here on this slide, next slide. So we are saying when we substitute these values in this formula, we will get the final answer as it is 16100 by 7 centimeter cube, that is equal to 23728.57, and this is equal to 23.73 liters. How centimeters are converted to liters? We are saying 110 centimeter, that is equal to 1 decimeter. So centimeter cube, we are cubing both sides, it is 1 decimeter cube. So we are saying 1000 centimeter cube, that is equal to 1 decimeter cube, and 1 decimeter cubes means we are talking about 1 liter. 1 liter is just 1 decimeter cube. So we are saying that 1000 centimeter cube, that is equal to 1 liter. So 1 centimeter cube is equal to 1 by 1000 liter. Now multiplying this value, we will get the answer as 23.73 liters. Now the next question we have is, a shuttlecock used for playing badminton has the shape of a frustrum of a cone mounted on a hemisphere. So this part we are saying this is the hemispherical part, and this is the frustrum of the cone we are talking about. The external diameters of the frustrum are, this is 5 centimeter and 2 centimeter, and the height of this entire shuttlecock, it is given to be 7 centimeters. So if we are talking about the base over here, we are saying the diameter over here, it is 2 centimeter. So this height we have, it is 1 centimeter, that is equal to the radius small r we are saying. This is the value of capital R we have. So the height we obtain over here, that is equal to 6 centimeters. It is 7 minus 1, that is equal to 6 centimeter. So the slant height that we will have, that will be equal to square root of 6 square plus 5 by 2 minus 1 square. So radius we have over here, it is 5 by 2. The radius small r we have, it is 1. So on solving this, you will get the value, it is square root of 36 plus 9 by 4. So that is equal to 153 by 2 square root. On solving this, we will get it is 12.36 by 2, and that is equal to, it is square root on the numerator part only, it is square root of 153 by 2. So the answer on solving this, we will get it is equal to 6.18 centimeter. So the slant height we have over here, it is 6.18 centimeters. Now we have to find the external surface area. So the external surface area means we are talking about the area of this portion and area of this hemisphere. So the lateral area of this frustrum of cone, the formula we have, it is pi L into capital R plus small r, and the lateral area of this hemisphere, it is 2 pi r square. So when we add these two values, the answer we will get, it is 22 by 7 into 6.18 into 5 by 2 plus 1 plus 2 into 22 by 7 into 1 into 1, and it is this much centimeter square. On solving this, you will get it is 11 into 6.18 plus 44 by 7, and on calculating this value, the final answer you will get, it is 74.26 centimeter square. So the lateral area we are saying, it is the lateral surface area of the frustrum of cone plus area of the base. Base means we are talking about, it is hemisphere, and this is frustrum of cone. So the final answer we get, that the total area, it is 74.26 centimeter square. Now the next question we have is, the slant height of the frustrum of a cone is 4 centimeter. This is the value of L that is given to us, and the perimeters of its circular ends are 18 centimeter and 6 centimeter. So the perimeter of this means 2 pi capital R is equal to 18, and perimeter of this end means 2 pi small r is equal to 6. So the value of R we will obtain, the capital R we will obtain, it is 18 by 2 pi, and the value of small r we obtain, it is 6 by 2 pi. Now we are saying the value of L that is given to be 4 centimeter. We have to find the curved surface area of the frustrum of cone. The formula for curved surface area, it is L, pi is common, it is capital R plus small r. If we substitute the values, it is pi into L is 4. The value of capital R we obtain, it is 18 over 2 pi, and the value of small r we have, it is 6 over 2 pi. So this 2 pi and this value gets cancelled, we are left with 2. So the answer we get, it is 2 into 24, so that is equal to 48 centimeter square. So we are saying that the curved surface area of frustrum of cone, it is 48 centimeter square. The next question we have is, the height of a cone is 30 centimeter. So this complete height, it is given to be 30 centimeter. A small cone is cut off at the top by a plane parallel to the base. This cone is cut off by a plane parallel to the base. If its volume is 1 by 27, the volume of the given cone, the volume of this larger cone, if it is V, and the volume of this smaller cone, it is given to be 1 by 27 times V, at what height above the base is the section made? So suppose we are saying the height of this cone, it is small h, the radius of this larger cone, it is r, and the radius of this smaller cone, it is small r. So this remaining height over here, this is 30 minus h. Now it is given that the volume of the smaller cone Now we are saying the volumes we are going to compare. So the volume of the larger cone, it is 1 by 3 pi capital R square, and the height of this cone it is 30, and the volume of the smaller cone, that is equal to 1 by 3 into pi into small r square into the height of this cone, we are saying it is h, and it is given that this value is 1 by 27th time this, so we are multiplying this value with 27 on this side. So this pi by 3 gets cancelled from both sides. So what we are left with is that r square into 30, that is equal to 27 r square into h. So this gives us that capital R by small r square, that is equal to 27 by 30 times h, and if we divide it with 3, we are left with is 9 by 10 times h. Now if we look at the triangle OAB, we are talking about this larger triangle OAB and the triangle OCD. Both these triangles, these are similar to each other because this angle over here it is 90 degree, this angle at O it is common. So by angle a criteria, we are saying both these triangles, these are similar to each other. So in these two triangles we can write OA, we are talking about OA over OC, we are talking about this length OA over this smaller length OC, that is equal to AB over CD. So this gives us the value of capital R over small r is equal to 30 over h. Now if we substitute this value in this equation, we are saying we are having two equations. One is capital R over small r, that is equal to 30 over h. Second equation we have is capital R over small r square, that is equal to 9 by 10 times h. So if we substitute these values over here, we will get it is 30 by h square, that is equal to 9 by 10 times h. So we get 30 into 30 into 10 over 9, that is equal to h cube. So this is 10, this is 10, this gets cancelled. So the value of h that we obtain, that is equal to 10 centimeter. So we are saying what is h? H we have considered it is the height of the smaller cone. So we are saying the height of the smaller cone is equal to 10 centimeters. Now the height of the section of the base, we are saying this portion we are talking about, it will be 30 minus 10 is equal to 20 centimeters. This height we are saying this is equal to 20 centimeters, and this is what we have to calculate, that is at what height above the base is the section made. So it is made above a height of 20 centimeter from the base. Now the next question we have is a hollow cone is cut by a plane parallel to the base and upper portion is removed. So a cone is given to us and it is given that the upper portion of this cone has been removed. So suppose this is the line we are saying CD, which is parallel to the base AB, and this is the upper portion we are talking about, which is being removed. If the curved surface area of the remaining portion is 8 by 9 times the curved surface area of the whole cone, suppose the area of the whole cone, we are saying it is area of the cone, the area of this upper part, we are saying it is area of the part which is removed, and this area we are saying this is the area of the frustrum of cone. Now what we have is in the given cone, suppose the height of this cone, say it is h, and the value of this height it is small h. The radius of this larger cone it is r, and radius of this smaller cone it is smaller. The slant height of this larger cone it is L, and the slant height of this smaller cone it is small l. If we look at these two triangles, one is OED and second is OFB. We have this angle at E and this angle at F. Both these angles, these are equal to 90 degree. For these two triangles, this angle at O, this is the common angle. So both these triangles, these are similar to each other. So we get that capital H over small h, that is equal to capital R over small r, that is equal to capital L over small l. This condition we are obtaining by basic proportionality theorem. Now again, when we come to this part that is given to us, that the curved surface area of the remaining portion, it is 8 by 9 times the curved surface area of the whole cone. So it is given that AF, the area of this frustrum of cone, this is equal to 8 by 9 times AC. This is one equation we have, and second equation we have is that the total area of this cone, that is equal to area of the region that is removed plus the area of the frustrum of cone. If we substitute this value over here, we will get AC is equal to AR plus 8 by 9 times AC. So it is AC minus 8 by 9 times AC is equal to AR, and this is equal to 1 by 9 times AC. So what we get from this is, I am showing the calculations on the next slide. What we have obtained is that AR, that is equal to 1 by 9 times AC. Now what is AR? It is the area of this we are talking about, the remaining portion of this cone, and the value of this area, the curved surface area we are talking about, it is pi r L, and that is equal to 1 by 9 times the area of this complete cone, and that value is equal to pi capital R into capital L. Now another conditions that we are, or other equations that we have already obtained, it is H, capital H over small h is equal to capital R over small r is equal to capital L over small l. Now from this equation, this pi gets cancelled. So what we get is, if we shift this R on this side and this L on this side, we will obtain L over capital L. This is equal to 1 by 9 times capital R over small r. What is the value of capital R over small r? We are saying we can substitute this value. In place of this, we are writing it is capital L over small l. So we are getting it is L square over L square is 1 by 9. So this gives us small l over capital L is 1 by 3. So we are saying this ratio is equal to 3 over 1. Now what we have to calculate in this question is, we have to find the ratio of the line segments into which the altitude of the cone is divided by the plane. So we have to calculate the value of the ratio in which these two altitudes, these are divided. It means we have to calculate the value of OE is to EF. So the value of OE, we are saying it is small h, and the value of EF we have it is capital H minus small h. So we can write it is EF over OE, that is equal to capital H minus small h over small h. This is equal to capital H over small h minus 1, and this is equal to 3 minus 1, that is equal to 2. So substituting this value over here, we will obtain this is equal to 1 by 2. So the final answer we will obtain it is OE over EF, that is equal to 1 by 2. So OE is to EF, this ratio is equal to 1 is to 2. So this is the required ratio. Now the next question we have is, a metallic right circular cone is 20 cm high and has a vertical angle of 60 degree. So a cone is given to us, and it is given that the height of this cone, the total height of this cone, it is 20 centimeter, and this angle, the vertical angle we have, it is equal to 60 degree. Now this is cut into two parts at the middle of the height. So whatever the height of this cone is, it is cut into two parts at the middle of the height by a plane parallel to the base. We are saying this plane, this is parallel to the base. If the frustum so obtained is drawn into a wire of diameter 1 by 16 centimeter, find the length of the wire. Now if we look at this point, say O we are talking about, this complete angle is 60 degree over here. So this angle over here, its measure will be 30 degrees. Now this complete length is given to be 20 centimeters. We are saying this is the point A, this is the point F, and this is the point B that we have. Now the length, this is C, E and D, and we are marking these points equal to this length, it is half over here. So we are saying this much portion, it is equal to 10 centimeter. Now we are talking about, once we are talking about the triangle, it is OED. This length is 10 centimeter. This angle is 30 degree. And once we are talking about the triangle, it is OFB. We are saying this angle is 30 degree, and this length we have, it is equal to 20 centimeters. So by using the trigonometric equations, we are saying the value of tan 30 in this triangle, I am talking about the value of tan 30, that is equal to perpendicular over base, that is equal to ED over EO, and the value of tan 30 we know it is 1 by root 3. The value of EO, this length EO, it is 10. So the length ED we get, it is 10 by root 3. That is equal to, if we rationalize this term, we are multiplying and dividing it with root 3. So it is 10 by 3 square root 3. So this length ED that we have, the value of small r that we have, it is 10 by 3 square root 3. Similarly, if we are talking about the second triangle, the value of this term, the value of this side that we will have, if we write it is tan 30, that will be equal to FB over OF, and the answer we will obtain, that will be equal to 20 by root 3. So it is root 3 by root 3. So answer we will obtain, it is 20 by 3 root 3. The value of capital R we obtain, it is 20 by 3 root 3. Now we obtain the dimensions of this frustum of cone. We are saying the value of this small r we have 10 by 3 root 3. The value of capital R we have, it is 20 by 3 root 3. This height we are talking about EF. This height we are saying this is equal to 10 centimeters. So if we substitute these values in the formula for the volume of the frustum of cone, the volume of this frustum we have, it is 1 by 3 pi h into r square, capital R square, plus small r square, plus capital R into small r. When we substitute these values over here, the final answer we will obtain on solving these values, these calculations are shown over here, and you should try these calculations at your own. The answer for the volume we will obtain, it is 7000 pi by 9 centimeter cube. Now what we have to do is, we have to it is given that if the frustum so obtained is drawn into a wire of diameter 1 by 16 centimeter, find the length of the wire. Now we are saying that this frustum, from this frustum we have drawn a wire, and the diameter of this wire, it is 1 by 16 centimeter. The diameter of this wire, it is 1 by 16 centimeter. So the radius we have, it is 1 by 32 centimeter. Suppose the length of this wire, it is L. then the volume of this wire, it is pi r square L, and this volume should be equal to the volume of the frustum of cone, that is equal to 7000 pi by 9. So pi gets cancelled over here, and the value of L that we obtain, that is equal to 7000 into 32 into 32 by 9 centimeter. Now if we convert this values into meters, so we are dividing it with 100 and this value is converted into meters. On solving this value, you will get the answer is 7964.44 meter. If we convert it to kilometers, so it is 7.95 kilometers. So this is the length of the wire that will be formed from the material of this frustum of the